All right, this is Dr. Hether with Daytona State College doing another experiment for digestive physiology using the PhysioX program, checking pepsin and the effect of it on the substrate BAPNA, which is a synthetic protein, as it breaks down the polypeptide bond that holds the amino acids, the proteins together, and liberating the amino acids. For the first one we're going to do is we're going to add pepsin, we're going to use BAPNA, and we're going to use a pH buffer of number 2. Remember, this is a acidic pH, but then again, this is taking place in the stomach, and we would expect to see pepsin working well in a low pH. The first test tube we're going to boil, like we did in the previous experiment, to see if having a extreme temperature has an effect of the effectiveness on pepsin. So test tube number 2 is going to be the same as test tube number 1, except for we are not going to boil test tube number 2. Test tube number 3, we're going to add pepsin, we're going to add deionized water, and we're going to have a pH buffer of 2. In this one, we actually are missing the protein. The test tube number 4, we're going to have deionized water, we're going to have BAPNA, and we're going to have the pH buffer of 2. In this one, we're missing the enzyme. In the next two, we're going to do the same as we did in test tube number 1 and 2, protein, pepsin, but we're going to have a pH of 7, and for the last one, we're going to do the same thing, but we're going to have a pH of 9. So we're going to alter the pH to see if changing the pH has the same effect, denaturing the enzyme, as boiling did. So for this one, we're going to incubate it for 60 minutes, which on this will take about 60 seconds. To test for this, we're going to use a spectrometer. A spectrometer is going to shoot a light or laser through it, and it's going to see if there's any refraction, if there's any absorbance of the light. And if there is light absorbance, we can tell that amino acids are present. But if there are no absorbance and the light has 100% transmission, then it goes all the way through. That means there were no amino acids to stand in the way or bounce off the laser light. I liken this to taking a piece of steak, put it in water, shine the light through it. The light's not going to bounce off the water, and it's going to go all the way through. But if we add enzymes to it and we start breaking down the proteins into amino acids, we have all this amino acids floating in the water, and when the laser goes through it, now we're going to have some of the light being bounced off because there are amino acids present in the water. Alright, so again, we're using a spectrometer for this. It has a wavelength of 405 nanometers. For the first test tube, we're going to check the optical density. We're going to analyze it, and we get 0. There were no amino acids present for test tube number 1. For test tube number 2, when we analyze it, we get an optical density of 0.4. So 0.4% of the laser light was not received on the other end, or it was absorbed by the proteins. Test tube number 3, we had the pepsin, we had distilled water, and we had pH buffer of number 2. Again, we are missing the protein, so again, we should have an optical density of 0. For test tube number 4, we had deionized water, we had BAPNA, we are missing the enzyme. With no enzyme, again, optical density of 0. Test tube number 5, if we look at the pH of 2, 7 and 2 are close together, but they're not great. We get an optical density of 0.03. We had some amino acids liberated, but not like the 0.4 that we had with the pH of 2. And when we check pH of 9, the optical density is going to be 0. 9 completely denatured the enzyme pepsin, whereas 7 mostly did, but we still had some amino acids that were liberated in this experiment. All right, and that's the experiment for pepsin on the effect of BAPNA utilizing a pH of 2, which was the most effective pH for this.